for inviting me here. It's a great city, it's a great country. It's my first time in Korea. And I hope that after this talk, you will get to use Facebook more. That'll be one of the goals of this. I'm going to share with you 2 case studies of projects that I've done at Facebook. And for you to take some learnings and how do we do things at Facebook. One is in marketing analytics, and the other one is in operation analytics, where we have used the platforms, the methodologies, and the sophistication of the ecosystem at Facebook to really help these teams to make decisions. Facebook leadership is very important, and I'm going to start with that topic because the company has empowered us to use these platforms, to extend them, but it's our responsibility to learn how to use them and also to convince, influence, and change the product decisions or the decisions that are made. At Facebook, titles are not very fancy. There are no executive vice presidents, presidents, or any of that. Titles are very deflated in that sense, but what is most important is individual leadership and how we use that to really influence products. Some context about analytics. To me, analytics is the art of counting things. And by that I mean, when we do an ad, when we have a treatment, when we have a new experiment, when we make changes, we hope that a certain number of people perform certain actions, and we count those users. And we compare the count of those users to a baseline or a control group. That's what I mean by count, the art of count. And in many cases, the count of counts, and I will illustrate this concept later, is what allows us to get insights and manage these things very well. In marketing analytics, typically what we do is segmentation, drill down, attribution analysis, and you saw all of this in the previous talk, A/B testing, cohort analysis, synthetic testing. I'm going to share with you some of those things where I get to use these methodologies, and when we interface with the different teams and we run predictive models. One important thing to notice is at Facebook, because as you can imagine, the network effects are very important. It's very hard to isolate things for testing. I cannot just isolate this group because this group are friends with this other group. And therefore, anything that this group sees or does has influence on their friends and their connections. So it just complicates things, and this is what is called network effects, and it's very typical of these large occurring social networks. And the other case study that I'm going to share with you is how Facebook also built smart workplaces. We also use analytics to make the place a better place to work, a place where people, smart people like you, will like to come and join and make it easy, not only as a benefit to employees, but also in many cases as a legal requirements or requirements of the counties and the cities, and I will share with you that. This is an abstraction of how the platforms that I, in particular, get to use very often. Obviously, Facebook has more systems than this. Facebook has sophisticated predictive models, sophisticated testing platforms to do A/B or network experiments. But in this case, it's an abstraction of the platforms that we use. And you can see in this slide that there is a trade-off between what is real time, what is very fast, how can I get some simple counts very, very fast, versus the length of time that I can store or have availability, and versus the complexity of the queries that I can perform. So in many cases, you can see if we are running an experiment, if we are running a campaign, if we are running an ad, I can go to these real-time systems and see in under a minute how anywhere in the world things are behaving. But I can only do that for a few days. If I need more sophistication, then I need other systems like Hive, where virtually the storage of data is unlimited, where I can move and analyze petabytes of data easily. The platform is available to me, but obviously it has a cost in terms of it's not real time. I have to wait a day or a few hours for the data to be available, and in many cases I have to wait for the data to be moved. But in marketing analytics, in many cases, this is perfectly okay, and this is really where I spend most of my time. And the marketing analytics team spend most of the time in this area because it allows me to do very sophisticated, very complex queries for attribution and for other type of modeling that allows me to really influence products and decisions and how things are being built in the areas that I have influence for. So why leadership? As I mentioned, titles don't mean much at Facebook. You would not see fancy titles. And really the power is not based on how many people report to someone, but it's based on the ability to influence, based on the ability to really change product decisions. In particular, the company empowered us to use these platforms, to extend them, to really do all this sophisticated work that any other company that I worked in the past would take a long time to do, will take a team of engineers to do. I myself, with very few lines of code, can move petabytes of information, can scan through them, can join these huge, very huge content tables to get the analysis that I want, and I don't need the help of anybody else. In some cases, I go to data engineers for help with certain things, but the company and the platforms allow me and empower me to do that. In return, I am accountable for learning how to use these tools. I am accountable for being able to persuade the product managers or the product marketing managers that are in the front lines of the product design. And I am very accountable and mutually accountable in these teams. Really, my influence and my success is measured by how well I work, not with my boss, not with the vice president of the team, but how well I work with the stakeholders on my team, the product managers, the product marketing managers, and they in turn are also measured, I would say, or evaluated how they work with me, and they are also accountable to me. And collectively, we work and we influence products. And that's really, really interesting. It's a paradigm of work that is not easily found in any other companies, as I said. And I'm going to share this particular product. The analysis that we did, my team is very small. We are only 4 people in consumer marketing analytics. This analysis would not have been possible without that mental paradigm of empowerment and accountability and the sophistication of the underlying platforms for you to use that. Probably many people here use Facebook. I've been asking around. I know this other application called Kakao Story is also very popular in Korea. But many people have used Facebook, and this product is called Look Back. Look Back literally means look back to your history on Facebook. It's like a reminiscence product where literally what you can do now if you want is go to facebook.com/lookback, and then a movie of your time on Facebook will be presented to you. And this is great. This is my particular movie. You can see some pictures here when my baby is born, when a friend was married, when I visited Las Vegas, when I was at a party. And it was a very, very good thing. I really enjoy seeing this movie. This movie for me was about a minute and a half of duration, very short. This product was used by millions of people worldwide, literally millions. It was so popular back in February that the engineers were afraid that the system would collapse because of all these people were creating these videos, sharing these videos, and the network, the virality of the product was really, really great. And we are going to do similar products in the future, like Say Thanks and many others. And one of the concerns is if this becomes really very successful, the platform really can collapse. I mean, imagine if 1.3 billion people in the world do this kind of at the same time, there is just no system in the world that can sustain such a lot. That's simply it's not possible. So we have to be careful with those things. But this product was very, very successful in that sense. Created great sentiment and trust about the company. People felt better about Facebook. People felt that the company does product for people like me, cares about me. All the indicators of sentiment in the surveys about how people felt really, really increased. So this was a very positive experience for the customer, for the users, and also for the company. One word about statistics. As the previous speaker mentioned, when you do measure, when you compare counts, when you compare metrics in groups against a baseline, there is always uncertainty. I cannot be ever sure that this product Look Back increase the number of comments and likes by 50%. That will always have some uncertainty. But what statistics tells me is that if I am very smart and I bet on the experiments that have a confidence interval like the green one, because I'm comparing the experiment C with my control, and the confidence interval does not overlap with that, there is a high probability that that metric is indeed higher. For instance, the experiment B, the one that you see in orange, is still higher than the baseline. And this could be anything. This could be an average. This can be the number of friends. This can be the number of comments, the number of likes. It can be anything. So even though V is higher than the control, the confidence interval overlaps and involves this. Therefore, statistically speaking, is not significant. C is significant because the confidence interval does not overlap with the control or baseline. However, this is not perfect. A 95% confidence interval means that 1 in 20 is still a false positive. A 99% confidence interval means that 1 in 100 is still a false positive. What this means is, in the overall things, if I keep doing these things consistently and betting and pushing the experiments that have this kind of confidence intervals, overall, it will be a winner. But once in a while, we will have these false positives as well. That's what this means, and we are very, very careful about these things when we measure, and this goes a long way about influencing, about telling executives and product managers about the confidence that we have in anything that we have done. So what we did for the look back video is, because the data, as you can imagine, is massive, it was nearly impossible to take all the millions of videos that were created, all the millions of users that created these videos, and analyze what kind of effect it had on their friends and what kind of effect their friends did on them as well. So it's very common in these situations to take a random sample and use some of these statistical methods to infer what can happen. Some of the key findings is that on day 0, and by day 0 means the day that these 100,000 people created their look back video. Obviously, many people do it in different days. Many people did it in February, in March, or April. We took a particular day where one set of 100,000 people did it as our random sample. And then we found very, very interesting things. In addition of the increasing sentiment and trust and favorability about the company, we found that these people got a lot of feedback from their friends. By feedback, I mean comments and likes. More friends liked that. More friends commented on that. The people that didn't receive anything was also much lower than usual. Usually you post things on Facebook and not necessarily your friends comment or like that. It happens. But in this case of the look back video, less people suffered that, I would say. Comments, likes, everything was very, very, very high. So this was a very, very, very powerful product. It was a very powerful thing to do. So the thing is, how do we know? How do we measure? How do we benchmark future products knowing what happened with this product? Again, what I did was we took a random sample. The random sample is the yellow square on the left. These people have friends. Those friends, also are influenced by the product, and this is a key differentiator here. It's a network effect. It's not just that these people are in isolation interacting with the product, it's that they also have connections and friends that get exposed to that. So you have multiplicative network effects. And we also took a random sample of people that did not create the video on that particular day, and took a sample of their friends as well. We analyzed some of the key metrics in terms of comments, likes, shares, time spent, and several other things on several days. On day -28, on day -7, on day +7, and on day +28. Because we want to analyze these two cohorts, these four groups, because in reality it's 4 groups, across time, and understand what was the effect on that. We did many comparisons, many things, but the key revelation And the key finding was this. So this chart shows two things. First, it exhibits one of the most important properties of a social network, which is a long tail. By that I mean long tail, In the vertical axis, what you have is the number of users that use the look back video. That's the vertical axis. And on the horizontal axis is the number of friends that commented or liked on those friends. This is what I mean by the count of counts. Typically, any one of us will have 300, 400, 500 friends, and some of those friends will comment or like things. I just posted a picture of me speaking here or in this conference, and I got 10 likes. You might have done the same, So he got 10, I got 15, and you got 12. That's very easy to compute. But what we want to understand is how many people got 10, how many people got 20, how many people got 30. That's what I mean by the count of counts. And that exhibits this property of social networks called power law, or a long tail. And long tail means that very few people, notice how short these bars are, very few people receive a lot of comments from lots of friends. Imagine that these are the rock stars of the world, the soccer players of the world. Shakira, Neymar, Messi, all these guys post something and thousands of people comment on those. I post something and I'm lucky if 15 people comment on things. So I'm really here at the right side of this, where most people like us just receive a decent amount of feedback, but not very much. Most people are like that. And then these stars, these high-profile people receive a ton. So what is key about this slide is, this is how we determine the success of this particular product, is you will see that the orange and the green lines are virtually identical. The orange and green means the distribution at the day minus 28 and plus 28. So it means that on any given day, these 100,000 people do something. They post pictures, they post videos, they do things, they receive feedback, and that feedback looks like the orange or the green lines. You will notice that the first bar is very, very tall. This first bar, very, very tall, meaning that even though people post photos or comment on things, they don't receive anything back from their friends. In this particular case, about 24% of people didn't receive anything. Notice how different the blue bars are. The blue bars are much shorter at the beginning and much higher at the end. What it means is that distribution is more uniform, meaning that more of the people on that day of the look back video receive more feedback, more comments, and more likes from more friends. So that's what it means. So when you compare the two distributions, you see that the shape is very, very different. The power law on the top means that most people don't receive much, and the power law on the bottom means that that is more uniform, more flat. Imagine that this is a scale with weights, and you calculate the equilibrium point. The equilibrium point, by definition, of the base is 50%. If you apply the same weights to your new distribution, you get a new equilibrium point. And notice how far to the right that new equilibrium point is. And that's the key metric that we are going to use to evaluate the influence that the people that use this product had on their friends. And this is the metric that we are going to use to evaluate future products like the look back, this displacement on what we call the average percentile. Again, the key here is to understand and come up with a metric that you can manage, a metric that can be compared, a metric that can be replicated, and a metric that can be used for benchmarking future products. So this was a key finding for us in the sense that conceptually and logically we understood that this was a great product. More people receive comments and likes, but by how much? This metric tells us by how much that happened. And this is going to be the benchmark for future products. This is a line, this is a slide with some lines of code. It might look complex at first, but the code is actually fairly simple. The code is nothing more than SQL lines. SQL lines are database programming code where you select embedded on a Python script. What this means is me, by myself, just coding a few lines of SQL code plus Python, I can access petabytes of data. One example is, even though the sample was small, the sample was only 100,000 people, something that you could think you could manage in Excel. Excel has 1 million rows capacity. What happened is finding the actions of these people and finding the actions of the friends on these people is very, very difficult because the table that stores that has petabytes of information. So you have to scan those tables to find what happened to those 100,000 people. So even though the sample is small, finding what they did or what their friends did to them was very, very difficult. But those platforms allow me to do that. Code, scan, join, and move petabytes of data around with very, very few lines of code. And that's really how the company has empowered us to do that. And as I said in the beginning, in many other companies, this would have been a project of several months, a project that would have involved data engineers with sophisticated tools to just move the data. In this case, it was just me doing that with this kind of code. And again, I could focus my time on interpreting the results, on preparing for the presentation, on informing the executives, on informing the product managers and product marketing managers about the effectiveness of this product. The second case that I want to share with you is operational analytics. The previous one was marketing analytics, where I illustrated how this particular look back, that again, I highly encourage all of you that have Facebook to go and check it out because it's fun, it's really cool. This is about the shuttle operation. By shuttle operation, shuttle means really the bus, the passenger bus. Facebook provides many benefits. It's a great company to work. It's very fun. In Menlo Park, California, you will see, you might recognize the map of the Bay Area in San Francisco. This is San Francisco, the city of San Francisco, and this is Menlo Park, where Facebook is located. And these circles are where the bus stops to pick employees every day. I take the bus every day. I drive to a parking lot that is 10 minutes away from my house. I take the bus, and the bus brings me to the campus. It's very nice. It's free. I have Wi-Fi on the bus. So it's not only convenient for employees to do that, but it's also very important for the company because traffic is really heavy in this area. It's very, very heavy in the morning and very, very heavy in the afternoon. So the cities and the counties don't like, thousands of people driving in and out of Facebook. If you can improve that situation with the buses, and the buses, of course, are environmentally friendly, you don't have as much traffic congestion, I feel much better, I can work on the bus. So it's a very important operation. It's a very expensive operation that the company needs to manage. So the challenge was helping the transportation team to come up with a metric that they could use to optimize this operation, they could be held accountable for, and they could use to plan capacity planning and several other things. Again, what you see here at your right is the map of the city of the San Francisco Bay Area. It's a little blur, but you can see the peninsula, and then what the dots indicate is where people live. There's a little randomization here for confidentiality reason or for privacy reason. I could not put on the map every employee that lives in the Bay Area, but this is an illustration of where people live. I am one of these dots over here. You cannot see the pointer, but I am one of the dots over to the right. The dots are color-coded based on the number of times each one of those people have taken the bus on any given day. The more green they are, the more times they have taken the bus, let's say in the last 30 days. The more red they are, the less time they have taken. So this is very informative at a glance because it tells you of the density of employees in the Bay Area, how many people are actively taking the bus, how many people are not. And again, it's very important for the team to know that, because ideally, the company will like a lot of people taking the buses on a daily basis. That's the goal. So we came up with this metric. We came up with this metric on the top. And again, this is back to my story of the counts of the counts. So let's say I take the bus at 8 and I get there by 8:50, it's 50 minutes. You take the bus at 8:30 and you get there by 9, it's 30 minutes. That's very easy to do on an individual basis. Rona takes the bus at 9 and gets there at 9:30. We know that on a daily basis. But what is key to know is how many people take 30 minutes, how many people take 20 minutes, how many people take 50 minutes, is the count of counts where you can get really cool insights and important insights. The chart on the top shows the distribution of those people on any day. Every row is one particular day, and you might not be able to see, but these are dates. These are days, day of the week, Tuesday, Wednesday, Friday, and so on and so forth. You like to see that. Where the blue squares end is where 90% of the people arrive on that day to campus. So what this metric is telling you is how long does it take for 90% of the people to arrive on any given day. It's not how long it took me, it's not how long it took Rona, it's how long for 90% of the people to arrive. So this is a key metric because it allows the team to plan, to add capacity, to understand what is happening, to compare day over day. And then you can see that very easily. It's color-coded. You will see on a daily basis also the map to the right, how green or how red is that. You can do surveys, you can understand if you need to plan for more capacity, you need to understand if you plan for more bus stops, things like that. And this is a metric that over time is fairly stable, and then if you see that metric increasing, it's time for more buses. And that's very key. Otherwise, the team will not know. It will be too late to react if the team just expects people to complain about those things. The chart on the bottom just is another view of the same on the top, but illustrates on a minute by minute how people arrive to campus. And this is determined because we do have electronic cards called badges. So we badge on the bus. When the bus arrives to campus, we badge at the door of the company. And those elements are recorded. Also, the bus is equipped with GPS elements, and every 30 seconds, it sends a signal to a server with the geolocation of the bus. So on any given time, we know who is on the bus, where is the bus, and we can do that analysis. And that's useful for emergencies, that's used for planning, that's used for many other things. And again, it's used for transforming that data into this kind of view. So on a minute-by-minute basis, you know where people arrive, because you also want a smooth operation. You don't want all the buses stopping at the same door and have 200 people through the same lobby. That would be a very bad experience. So this dashboard, that's what it does. Again, the key here was coming up with that metric. How long does it take for 90% of the people to arrive? Operationalize that using the big data platforms that we have, making sure the metrics are not that hard to calculate, but you have to be smart about first understanding the business, first understanding how the metric is going to be used, and operationalize it and put it into a nice dashboard that can be viewed on a daily basis and can be managed. So to summarize, I illustrated two projects that we work where we use and leverage the platforms at Facebook. Again, the key thing is leadership. The key thing is how we take all those models, all those platforms, how we are empowered to move data, to create new entities, to use sophisticated models for particular purposes. And we don't get to use large teams. We have to do it ourselves. We are accountable for learning. We are accountable for understanding and influencing that. The key to this project was leadership, individual leadership. And again, that to me is empowerment and accountability. How we did that. And I illustrated how we did the analysis on the look back video that was a very successful product that we are going to launch several others this year and next year that hopefully will have the same effect, and how we also did that on operation and analytics to create a better place to work, a smart place to work. So with that, I will open for questions.
예, 질문 받겠습니다.
You mentioned about the team, how you cooperate each other. So I'm wondering what kind of team you actually have in Facebook and what kinds of role and if each person has it.
Sure. I am part of the marketing analytics team, consumer marketing analytics, which is a fairly new team. So Facebook is 10 years old. The company is about 8,000 employees, but it's been growing fast in the last 2 years. You can imagine that most of the people that work at Facebook are software engineers. Most of the people. Recently, they start hiring some people in product analytics and marketing analytics, but the consumer and marketing analytics, in general, the consumer marketing team is fairly small. The chief marketing officer has been there for less than a year, so we are building that team. My particular team is only 4 people. But 4 people, we do primary and secondary surveys and research. I do analytics, and obviously we have to work with other analytics team because we are very small. We have to leverage those tools. But again, it's not our titles, is not how many people we have, is how we collaborate with other functions, and we can use that and leverage that to influence these decisions. And this particular analysis is going to influence how the next set of reminiscence product, like the look back, is going to be done.
I'm very curious about why you extract your samples when you do the project look back. You extracted approximately 5 billion, but you can use all of the populations in data in Facebook, right?
Well, yes, but that would have been a very expensive analysis. So just to rephrase the question is, why did I use a sample instead of using the entire population? Several things happen there. On a daily basis, the information of the company has about 840 million daily active people. 840 million is a very large amount. Those 840 million people create content, interact with the site, they like things, they post things, they comment on things. They might generate anywhere between 20,000 million and 30,000 million events per day. Those people. So the information is massive. We take a sample because we have to pick a day, because navigating the different days is very, very expensive in terms of computing power. Even for Facebook, even for the data, the massive data centers, even for the massive Hive clusters, navigating a table of 20 billion rows on several days is a very expensive proposition. So we have to simplify things. And again, when I take a sufficiently large sample, the results are valid, statistically speaking. I might get to the same insights and the same recommendations if I take the entire population. And the analysis will just be simpler and more condensed. That's why I took a sample. We took a sample on that in these cases.
So whenever you have a project in Facebook, so you always took samples because of some...
Not always, but it's very common to take samples. Some of the real-time systems that I mentioned at the beginning, they do sample data. They do sample. Specifically, when products get used by millions of people, you don't have to count all of them. You can sample 1%, 10%, 5%, and those things are much faster to collect, takes less storage, and again, the analysis is valid and relevant. So many systems are sample systems, other systems are complete systems, but again, querying that is very expensive.
Thank you for your presentation. And then regarding the look back, the data analysis, Well, I'm wondering about how long it would take because you mentioned about the data size was about the petabyte, so it will be very, very large. So just I'm wondering how long it would take, and then did you just save all of them, or just did you just treat them and trash it away immediately?
I'm sorry, I didn't understand the last part of the question. The last part.
To make a result, how long would it take? Like the
Sure.
data.
Sure. There are different systems in the company. There are systems that are very, very fast. Specifically, the production system. Just to give you a comparison, if you post a picture of me right now on your Facebook page, that is visible immediately, right? Those systems are very fast because those systems are operational. However, if you want to find out how many actions 100,000 people took on any given day, then you will have to query this other Hive system. And again, you will scan a table for one day, you will scan a table of 20 billion rows. That also depends on what kind of pipelines you use. These systems are divided into namespaces and pipelines. I might take a high priority pipeline, but I'm not the only one using that. I might not be allowed to do that. If mine is not a very high profile or high request, I might take low priority pipelines. So I have to balance the needs of others. My query is not the only query running. My query, if I can afford to wait, because for marketing analytics, in many cases like this, I don't need real time. So I can afford these queries to take hours. And in many cases, those scripts that I showed you took hours to run, overnight. In many cases, I fire a query on a Friday afternoon to get the results on Monday. Because I say, I don't need this urgently. I can afford to use a low priority pipeline to do that. I don't want to disrupt oil production operations. I don't want to abuse the system, right? Obviously, those balances play into consideration. But again, if it's just a production query that needs to be completed very, very fast, then I will use a high priority pipeline, I will use a near real-time system, and those queries will take minutes. So it really depends.